Hey everyone, today's lesson is on rate of change and slope. Slope is the tilt of your function or your line that you're going to see on the graph, often referred to as rise over run, the difference in your y direction divided by the difference in your run direction, your x direction. To find it, you can take any 2 points from your graph unless your problem, your directions tell you to take a certain 2 points that they want you to find the slope for. If they don't, you can take any 2 points from your chart or your graph to find the slope. And what you're going to do is you're going to take the difference in your y values divided by the difference in your x values. So I've got 2 points selected here. Let's say that our linear function went through the points 0, -4, and 5, 6. So let's take a look at where these are. 0, -4 would be here, and 5, 6 would be here. You don't really have to see these on the graph to find your slope, but sometimes a visual can help you see exactly what we're referring to. So let's say I've got a linear function that travels through these points, and I would like to know the slope or the rate of change of that function. What I'm going to do is take my y values, which are here, up top, -4 minus 6, and divide that by my x values, which are here, 0 minus 5. So you can see if we calculate that out, we are going to get a result of 2, which means this has a rate of change of 2 units. Oftentimes we like to think of slope as a fraction, rise over run, so if you're needing to look at it like that, you can always put your 1 underneath your whole number, because that doesn't change the value of your whole number. And now we've got a slope of 2 over 1. 2 units in the rise direction and 1 in the run direction. 2 up, 1 over. You can see if we go from any point on this line to get to the next point, we would need to travel 2 units up and 1 unit over. Okay, so I can find slope by using my formula, and then once I do that, remember, for review, we're going to move in the direction of the movements. Ours was 2 over 1 to find each new point. So 0, -4. We found our slope to be 2 over 1, so if I travel 2 units up and 1 unit to the right, let's just make sure we do hit our point 5, 6, and there it is. Okay, what happens if we calculate our slope to be 0? Well, here's a couple of points that would give us a slope of 0. Let's take a look. If I was looking at the points 3, 5, and -2, 5, I would go in and take the difference of my y values, 5 minus 5, and divide by the difference in my x values, 3 minus -2, and calculate a slope of 0. And what's happening there is that I have a horizontal line somewhere on my graph that has no slope. It does not have a tilt, so we say the slope is 0 for a horizontal line. Sometimes we may be looking at the special case of a vertical line. For instance, if you have a line going through the points 2, 4, and 2, 7. Calculating your slope, difference of y's over difference in x's, you are going to get some number divided by 0. We can't divide a number by 0, there is no answer for that, so the slope of a vertical line is going to be undefined. And that kind of line is going to look something like that on your grid. Now, let's say you're not dealing with a linear function. Let's say you're dealing with some other function that may have a curve to it, and you're asked to find rate of change or slope for that function. You may ask to find what's called average rate of change. Let's take a look at this function, y equals x squared. If I tested some values into this function, I would come up with this curved quadratic picture. That's not a straight line, but I still may be asked to find the average rate of change over some interval. And I can't give a certain number that is always the slope there, but it's just going to be the slope on average. That's what they're asking for, the average tilt or the average slope there. So let's say I need to find the average rate of change for this function from the interval from 0 to 2. Let's say I would like the average rate of change right here. It's not going to be a consistent, steady number, but we can calculate what it would be on average. So y equals x squared is our function for this picture. Remember, we're finding the average rate of change from 0 to 2. So let's create ourselves a little chart. We're going to test 0 and 2 to get our matching y's here. So if I plug in a 0 to this function, I'm going to have y equals 0 squared, which is 0. And if I plug in a 2, I'm going to have y equals 2 squared, which is 4. So here are my ordered pairs that I can now put into the slope formula that I showed you earlier, the difference in y's over the difference in x's. So let's take our y values and find the difference there. And then we're going to put our x values on the bottom. And we are going to have 0 minus 4, which is negative 4, over 0 minus 2, which is negative 2. And when we simplify that, we have positive 2. So our average slope, or our average rate of change on that interval of the curved picture, is 2. Again, up 2 units over 1 unit. Not a steady increase, but just an average. And this concludes our lesson on average rate of change and slope.